Hey everyone, and welcome to another challenge video. Today is Sunday, so we are doing another challenge video. This is a challenge that has already been completed. I did want to just go over it since it did highly intrigue me a lot. So let's look right into it. So the challenge is an integer value of Roman numerals. And the challenge reads, the numeric system represented by Roman numerals originated in ancient Rome. Numbers in the system are represented by combinations of letters from the English alphabet. Roman numerals, as we use them today, are based on 7 symbols: I for 1, V for 5, X for 10, L for 50, C for 100, D for 500, and M for 1000. You have a string S that represents a number written as a Roman numeral. If the string S is a correctly written Roman numeral, return this number as an integer. If S isn't a correctly Roman numeral, return -1. For this challenge, assume that there is no restriction on the maximum number that can be written in Roman numerals. Typically, there is a maximum number that you can write in Roman numerals. You can't have more than, I think, 3 of the Roman numerals together. I know that that is true for any of the lesser ones, but for M, I think that you can't have 3, but in this circumstance, you can have as many M's as you want. So the way we're going to have to figure this out is, one, we're going to go over the string rules for Roman numerals, and then we're going to have to go over the numerical rules for Roman numerals. And so let's just get right on into that. So let's go over to the handy dandy paint to talk about it. So we have, we have Roman numeral rules. So we have our Roman numerals. Getting slightly better with my handwriting. We have I, which equal to 1, V, which equals to 5, X, which is 10, L, which is 50, C, which is 100, D, which is 500, and M, which equals 1000. So the string rules, or character sequence rules, I'm just going to call it string rules, is you can't have more than 3 of the same letters together. So in this case, I can have I, which is equivalent to 3, but I cannot have I, which equal to 4, or based off my handwriting, 9. It can't equal 4. Now, there are certain areas of the world that do use the 4 I's for 4 to recognize that, but that is a very special rule. It's not a widely accepted rule. So in this case, we're just going to ignore it. Then I can't have repeated non-repeatable sequences. Again, sorry for my handwriting. I'm still not used to writing on a tablet, on a PC. But this basically means that if we have a repeated non-repeatable sequence, we're already in the wrong. Now, what is a repeated non-repeatable sequence? Well, repeated non-repeatable sequences are sequences that usually have 4 or 9 in it, such as 4, 9, 40, 90, 400, and 900. You can't really repeat those. And by that, I mean you can't really have IV repeated multiple times. You can't have IX repeated multiple times. You can't have XL repeated multiple times. It's items that you just can't repeat multiple times. This is supposed to denote the end of a sequence, or denote the end of this multiple. And then there's another thing that goes into place. So you have your string rules, and then you have your mathematical rules. So if we move over, I can zoom out. Don't know why it zoomed me in. If I can zoom in and just move on over just a tad bit, we can go over some mathematical rules, which would be the powers of 10. So 10 to the n. And by this, I mean if we have the number m, c, m. So this is 1900, and then we'll go with x, c, 90, and 9, which is ix. So by this, this can be easily broken down into the tens places of this is 10 to the 0, 10 to the 1, 10 to the 2, 10 to the 3. So this is 1000, this is 900, this is 90, and this is 9. Altogether, 1000 plus 900 plus 90 plus 9 equals 1999. That's what it would be for 1999. And then 2000 is very simple, MM. But that's how things are supposed to go. It's supposed to go into a power of 10. This is kind of goes hand in hand with the can't have repeatable, non-repeatable sequences, because 4, 9, 40, 90, 400, and 900 are typically ends of a power of a 10. So if you have multiples of these, it wouldn't follow suit of powers of 10. So we have to take a look onto that. So I think this is really everything that we have to go into our code. But let's break down how our codes function. So if I were to just extend this down even further, keep on extending it as much as I can. Then let's just paint it black. Then go back to our brush. So our code. Nope. Gotta bring that back to white and basically put a line. And we're going to go over our code. So our input is a string of Roman numerals, and our output is either the integer representation or -1. It will return -1 if it fails, and it will return the integer representation if it doesn't fail. So what we need to do is, one, check string rules. So we want to make sure that we have a string to start with, and we want to check, does it follow the string rules? If it follows the string rules, then we're all good, we can continue. If it doesn't, we automatically return -1 before we do any more operations on it, because if you try doing more operations on it but you've already failed way before, you're just wasting time. And then 2, we will convert to numerical values. 3, check mathematical rules. So we're going to check the mathematical rules once we change it to numerical values. We can kind of do that at the same time as we're converting to numerical values, and that's what I'm going to do in our actual final product of the code, because those two steps can really go hand in hand. And what we're going to do after that is sum all up, sum all values, and then we're going to return. And so what I'm asking for step 1 and step 3 is return if fail. So I'm just going to make sure I take note of that, return if fail. I'm going to take steps 2 through 4 and put these together, because really you could do all these within the same step of codes or the same area of code. So that's what I'm going to do. So let's head on over to the code and go over it. So if we go over to the code, this is what I have currently. This is the method that we get when we first start out. We have a simple method that is asking for an integer for return type, and it's giving us a string for our input type. So what I want to do is simply make a method. Something's going on. It must have like a sticky key or something. There we go. Okay. So I'm going to write an if statement if not fail string rules s, return -1. Or if I fail string rules, I return -1. So I want to make a method that's called fails string rules with a string of s, and I want a return type of a boolean. And what we're going to do here is we're going to put in all the different rules that this has. So I'm going to write this in kind of easier terms to figure out, but I want to put out all the unrepeatable sequence is in here as an array, since we're going to compare it easier that way through an array. So 4, 9, I think that's 40. Yep, 40, 90. Oh wait, X, C, yeah, 90. CD, CM, V, L, and D. Since we don't want to repeat these items multiple times. We wouldn't want to repeat V, L, or D multiple times. They could be in multiple representations. We don't want to repeat them because it makes little to no sense why we would have like CD and then D again. It makes no sense. Instead, let's use one of the higher value numbers. Same thing if we use 2 V's to represent 10, like we might as well just use X. So it is illegal to do such things. So we say we can't repeat those. And I'm going to go in and I'm going to say for string of value in unrepeatable sequence, if s.index of, so s, which is the string that we're taking, if I check the index of the value that we have, and I'm trying to see, do we have a repeat of it, index or last index value of value. If this returns true, I want to return true in this case. I want to fail. I want to fail out. So what this is saying is that if my original, if I have an index of the value in S, I want to make sure that that is the last index that I have of that value. If that last index is somewhere else, or not the same number as the original index that we found, we want to return true because that means we have repeated a unrepeatable sequence. So we want to make sure that that is false, or we want to make sure that we don't do that. So we return true if we did do it, meaning that we failed. And then the other thing we need to check is if it contains sequences that make little to no sense. So if it contains 4 i's, if it contains 4 v's, if it contains 4 x's, and so on and so forth. We're going to just have to fill this out of 4 l's. S dot contains 4 c's. S dot contains 4 d's. And the very odd case of S dot contains XLX. Since XL would be caught, we're not checking another index of X. So we need to catch this odd case because our unrepeatable sequence does not catch it above. We need to return true here as well. Otherwise, we just return false. So that's how we are going to check for those values. And I can easily return 0 right here and run some samples, and it should catch some of these items already. So in this case, XLX, yeah, it's an odd case. I should return -1. I do return -1. In this case, V shouldn't be repeated twice because that gives us 10. Just use X. So we give out -1. 4 i's, that makes no sense either due to Roman numeral rules. So we are going to return -1. I assume you guys get the point, so I'm not going to go over that last test case statement for it. So let's continue. So now we're going to convert the string values to numerical values. And what we're going to do is we're going to do string, and we're going to write in the possible values in another array. So we have IV, IX, XL, XC, CD, CM, I, V, C, D. Oh, I'm missing one. I'm missing a couple. X, L, C, D, and M. Those are all the possible values that we can have as Roman numerals. You're probably questioning why I'm having IV, IX, XL, all the combination of subtractions previously or prior to the normal ones, and I'm going to show you in a bit on why I'm doing it that way. So I'm going to do int possible value integer, which is going to be the integer conversions of this, which is 4, 9, 40, 90, 400, 900, 1, 5, 10, 50, 100, 500, and 1,000. These are the integer calculations or integer representations of the array above. Then what I'm going to do is I'm going to go through the pos value. It doesn't matter which one, but I'll do pos value string version. Length I++. We're going to go through and we're going to set s equal to s dot replace all of pos values I with pos value int I plus a space, so we can easily split it later down the line. So what this is doing is it will go in and replace the sequence of characters that it gets in the first parameter with the sequence of characters it will get in the second parameter. This really goes hand in hand with why we're doing the subtraction-based ones first, because if we were to do the regular number ones first, that means these would be changed first from the string, and these ones would never ever be touched. So in the case that we do the normal ones prior to the subtraction based ones, if I have IV, instead of getting 4, I will get 1 and 5, which would give me 6, which is not something we would want. So we're doing the subtraction based ones first. And then I'm just going to say string int values, and it's going to be an array as well, equals s.trim, because if I'm on the last value, I could get an additional space at the end. I just want to make sure I trim it out so I don't get any further errors later down the line. And I'm going to split it with a space. So what this method is going to do, or what this line is going to do, is it's going to give me a string of arrays, or a string array of s after it has been trimmed down, so any additional white space gets deleted. And also I'm splitting the item so that I split it on spaces. So if there's a space, I'm going to say every single time there's a space, make a new string and add it to my array. So I will get a new array with each individual string value or string representation of the integer number that we want. Then we're just going to go through and count up and check for mathematical rules. So this is where I'm going to create the summation. So I'm going to make my integer of sum, and I'm going to go through and say int I equals 1, I less than int values dot length, and I'm going to count up, and I'm going to make int1 equals integer dot parse int, which will take in a string, parse it into an integer, and return that integer value to me of int values I minus 1. So it's going to give me I minus 1, which is the left value, and I want the right value as well. int2 equals integer parse int values of I. This will give me the right value. So this will give me the left value, and this will give me the right value. I just have to change this because it is a character mismatch. So my cases wouldn't match, so therefore I get an error. But what do I want with the left value compared to the right value? Well, I want to make sure that the right value is always greater, or actually always less than the left value. The left value should be the greater value at all given times. If the left value is smaller than the right value, then I know we are in not mathematical correctness. We have broken a mathematical rule of the powers of 10. So I want to make sure that the right value is always less than the left value. If it's not, then we return -1 because we've broken the mathematical rule that we've set up for ourselves. So if int1 is less than int2, return -1. Otherwise, we are just going to count. We're just going to add this to the sum. So sum plus equals int1. And since we have an index of 1, we're going up to values at length, we need to make sure that we add in the last value of int values. So if I plus 1 equals int values dot length, then let's add in int number 2 as well. This is going to make sure that we add in the last possible value in the array, so we're not missing any values. If I didn't add this, then we'd be missing the last value, the smallest value, the ones value basically, is what we'd be missing. And then I'm just going to return the sum. So before I hit run sample test, I just want to go through it to make sure that the code is correct. So what we're doing first is we're checking our string rules and making sure that if we don't follow our string rules, we just return a -1. I'm doing this in a separate method, so this whole method is not too big. Sometimes you do really want to break out your methods, so therefore your methods are reusable by other pieces of code. If it does a value on itself, usually if you need something to return a bool or you need something to return something, you typically want to allow it to be its own method so it's reusable if you can use it in another location as well. So that's what we're doing. We made another method to make it reusable, and we call that method. Then we're converting the possible values into the string by replacing all the values. So we replace all the string-based values with a integer version of a string into the string again. Then we're going to split it up into each individual integer value as a string. Then we're going to start counting our sum. We're going to convert the left value and the right value into integers, compare the two, and then if the right value is larger than the left value, we know we broke a mathematical rule. Then if we didn't do that, we will add it to the sum, and we'll do that all the way through all the values. And if it happens to be the last time that we do it, we want to make sure that we add that last value in as well. So if I hit run samples, let's see, are we correct or do I have an error? We are correct. I have 11 out of 11 sample pass tests. So we're all good, and I'm just going to submit again, see, did we get this fully correct? We got this fully correct. So that is how we do it, guys. That is how we take in and make our challenge easily done. Thank you all for joining me today. I will see you guys next Sunday for our next challenge.